Hi, it's Mike Stevenson. In today's video, we're going to take a look at a quite advanced scenario here where we're going to look at testing a Logic App agent loop and how we can use the Microsoft unit testing framework to test that. So over here in my solution, you'll notice I've got this workflow called the order decision maker. So as we get into some of the more advanced scenarios, we're going to look at how we can leverage a different end-to-end process of which this decision maker is going to be part of it. So this workflow I've opened up here, and you can see we accept an HTTP request. We're then going to call our agent here. Now I'll show you the instructions and things for the agent in a moment. We then have two tools. So if you imagine we get an order passed in, and the idea is to work out, is the order a high value order or not? So the two tools we've registered are get customer value, which is going to call into a child workflow here where it'll get the customer value. And then we're going to call a tool called get customer history, and that'll call into a child workflow here for getting the customer history. Now there's a couple of really key points here I think that will help people when you want to build testable logic apps. So for me, when we start thinking about the mocking that we need to do, the more code we have inside the action for each of the tools, the more difficult it's going to be to test this logic app. So one of the things that I did is I decided to use a child logic app for each of these. So you'll notice the get customer history actually maps to the tool for this workflow over here, and the get customer value maps to this one here. Now what I'm able to do is in those child workflows I can implement all of the complexity for getting all of those, processing that bit of data, performing the action we need performed. I can test that on its own as a building block, and then I can use it within my agent loop. So there's a couple of really good things there. So for me, the tool then becomes, robust before I start using it would be number one, but it'll also simplify the testing of this agent loop logic app, which, in theory, this could get quite complex to test. So we're breaking it up into composable pieces, which will make the process much more testable. Now, what I'm going to do here, if we have a quick look at the agent itself, so we can see, in this case, we're using the GPT 4.1 model, and I've got a system instruction here which says you're an agent that teaches me how to process orders. You'll look up the customer's history. So I'm expecting in this case it'll make the order history tool used. You'll also look up the customer's order value. You'll decide if it's a VIP. We don't want to use just the value indicator. We also want to look at some of the previous orders. So this customer might make a small order now, but the last order they might have made was maybe huge, and we may expect them to make huge orders in the future. So we want to try and give special treatment to VIP customers. And then I've said I want to return a JSON object with a VIP as true or false and a reason why you made this decision. So then we've got the tools specified here. We've got the child workflows. You can see we're passing in customer ID, and they'll go and do their thing. And after we've executed that, the response will basically be the agent's response message. So it's a fairly simple workflow here, but it is using the agent loop. So we're going to have a look at how we can test this. Now, over in my test project, so I've got my order decision maker folder over here, and when I've generated tests for this, we get our mock outputs. We've got the order decision maker test that I've asked it to create from a run history, and then I've got my mock JSON here, and I've got my my class to execute the test. Now, note I've also put I've put a text file in here as well. So we'll just take a quick look at that text file for a moment, because what I wanted to do is have some text that would be returned from my mock as the order response. So in here, for example, it's just some notes for the order history. It's not a well-structured object. It's just really free text about the orders. Now, in the mock data, you can see we've got the HTTP request that's received, and this contains, down in the body here, this contains an example order object that might be passed into this process. So you can see we've got some detail down here of the order and its actions and stuff. But one thing to note here is this doesn't actually mock the call to the AI model. Now that's a really interesting challenge in this scenario, because while we can mock the other actions, the runtime at this point in time in September 2025 doesn't support mocking that AI agent kind of action. So that bit, when we run this test, it's actually going to call out to Azure OpenAI at that point, but the other bits we can mock. So it's really important to understand what is supported and what isn't supported for mocking. And I think for me, it's going to be interesting to see what Microsoft do in this space, because the other cases, it's really just a one call gives one response, but with the AI model itself being able to make callbacks to trigger different things to happen, it's going to be really interesting to see what Microsoft can and can't do in that space to be able to decide how they'll be able to mock that. Because obviously you're going to, if you think in my case, I'm going to send one message and it may trigger two tools or more. Now, we'll have a look at my test class here. So you can see straight away this is quite a big class with quite a bit of code in it. So the top here, we've got all the usual stuff that gets generated when we generate a test. If we go a bit further down, so I've got two tests. One is the customer's expected to be high value and should be a VIP, and the other test, I think they shouldn't be a VIP. Now, one thing to probably note here, I've got these variables at the top. Now, because I think there's a couple of things here. Number one, the first challenge I mentioned previously, I can't mock the OpenAI call. The other thing is, in the run history, we don't really get access to the actions for the tools like we did elsewhere. So the first thing here is I'm going to pass in a value of, I'm going to use a customer lifetime value of 99, which should be high because I think it's a 0 to 100. But what I'm actually going to do when I do the mocks, I'm going to do a variable so I can track which mock got called, which we'll have a look at in a moment. So if I scroll a little bit further down, you can see we start off by setting up our mock data. So that's going to load that JSON file with the mock for the trigger, so that that request trigger action. I'm then going to set my mock up for the customer history here. So what I'm doing is I've specified this get customer history action. I'm creating a new object here, and then I'm using this on get action mock, and I can basically define here the details I want passed back. So we're going to pass back that it succeeds, and then here I'm going to read that text file which has the customer history in it and return that as the body for the the tool getting the customer history. Actually, the other point to note here is when this. So if you imagine when the test runs, the logic app is going to get to the point where it calls this child workflow, which will trigger this bit of code to execute on the fly here. Before I return the object, I'm going to set that variable to true here. So this is where we would know that the customer history tool got executed. Now I could save additional data if I wanted. I could maybe save some of the data that got passed through to it or something like that. But the key bit, in my case, I'm going to tick that the customer history tool got executed. So if we go further down, the next mock is for the tool, which is the customer value indicator. So here we're going to do a couple of things. It's the same approach. The workflow runtime is going to trigger this mock dynamically to get the data for it. When that happens, we're going to tick to say, set that value to true to say our customer value tool got executed. We're going to pass back a success message, and this time we're going to pass back a JSON where we set the customer value percentage to be the value at the top of the test. So that would be our mock setup, and then we're then going to do some standard stuff up here. This is how we usually trigger the test and start it executing. We're then going to, so I've got this helper that I've set up that we'll have a look at in a moment. So the helper's just really for logging, so it'll help me troubleshoot a little bit when I want to log some stuff. We've got the assertion here of the default agent, so this is the action that we're going to get. So we're going to have to get this action to reference stuff. We're going to check it was successful, and we know that that means it called OpenAI successfully and got responses back. So as we go further down, we're then going to check the response message at the bottom was successful. So after the agent loop, we successfully returned a response. Now, this bit here is the bit that we need to kind of figure out. We probably need Microsoft to be able to make changes to support this. So one of the things I was wanting to do, you notice here, was to get the action from the agent for the child action of the tool executing and make sure that was successful. So this is the bit I couldn't get to work. So this is why, as an alternative workaround, I've put the assertion of those two variables, so I know that the customer history and the customer value are both executed fine. So next up, I'm going to do a validation down here of the response action. So here you can see we get the output from the response action. I then query using jQuery to get the body. I'm then going to parse that, and I'm going to check here the value. So I'm checking the isVIP value is set to false, and if I can make that assertion, then we can check the customer should be a VIP. Now, if we look at the other test, so here we've got one where it's about the tool failing. So we go through, we've got the same setup over here for the tool itself. We've got the mock actions, but here the one that we're going to make error is the get customer history. Here you can see we've indicated that it should fail, and we've given like a bad request code and an error message here. So we're actually going to drive the workflow to fail. The customer value we're also going to make fail. So if you notice, we've set that to return an error. We then trigger the test as normal, and we're going to make some assertions. So the couple of things to check for the assertions here are, number one, that the two tools were both executed. So you can see we've got the customer history and the customer value both got executed. And here we've got the assumption that the workflow should fail for this test. So that would test the error conditions here. And then we've got a final test where the customer should not be a VIP. So we've said the customer value is 5, so they should be low value. And then basically this test's pretty much the same as above, where we've read the customer history, we've specified the customer percentage value here, and then we're making similar assertions. We've got the same limitation as before, that we can only check those variables rather than the actions. And then the key bit down at the bottom here is that isVIP should be false. Right, so here at this point we've gone through 3 test cases for this ordered decision maker. So we've mocked out the child workflows that are going to be called when the tool gets executed by the AI. as I said, we can't mock out at this point the AI call itself. So let's go and have a run of these tests, and we'll see what happens to these. Okay, so this is really interesting. So our green path, high value and low value, um, were successful, and they got the right output that we were expecting, which is really good. The one that failed, the error, we expected that to fail. Now, what's quite interesting there is the when the tool itself fails, that returns an error back to the AI. So if we think back to our logic app here, so this tool and this tool both fail, but it doesn't mean the agent fails. So the AI just gets back error conditions, but then it'll successfully return some interpretation back to the workflow, and the workflow will just continue. So actually, I'm going to leave that in as a test that deliberately errors. Now, what I might do in my workflows, if one of these tools failed, I might implement some logic to make the workflow error out or something. Or I could make the agent tell me in a response if it got an error process and stuff, so I can build some error handling logic. But I think this is really good to understand the behavior of the default agent here. So the agent, if your tool gets an error, it doesn't necessarily make the logic app fail. Okay, so hopefully that video was a nice short one covering a relatively complex scenario. So remember, the key points are using the child workflows in the tools for the AI agent makes the workflow much more testable, because I can test both of these in isolation before I use them in my agent. Key point 2 was I can't mock the agent itself, but I can mock the tools. I can't really read the run history for the tools, because I think maybe there's a way I can figure out to do that, but at this point I haven't worked that out yet under the hood. But I can use variables and state within the test from the mock framework to be able to work out what's going on, so I can still do quite a rich test. And in the other tests where we clearly could show that you can very high level of confidence in the test, and you can get 90, 95, 100% confidence that you've thoroughly tested the workflow. The agent loop, I would say you're probably like 70, 80% there. You can't mock the call to OpenAI at the minute, but actually that's probably going to bring in a whole bunch of extra complexity. So that that you are going to trade off, maybe in this scenario, testing it fully locally in a disconnected fashion may have some limitations, but hopefully what we really want to do with our tests here is reduce our risk, which is really what testing is all about. We need to improve the quality of our code, reduce the risk of errors, reduce the risk of unexpected behavior, and then we'll have a better solution the business are happy with. So in this case, for me, the testing we can do with the framework moves the needle significantly in reducing that risk. Thank you for listening to today's video, and we hope you're enjoying the series.